Good day everyone. Today we shall be considering part 2 of our complex number. And in today's class, we shall be considering addition and subtraction of complex number, multiplication in complex number, division in complex number, and equations involving complex number. By the way, this is Gifted Brain aka Saizu, first in Africa, sixth in the world. Now let's take the A part of this addition and subtraction in complex number. Yes, the A says 7 plus 3i, all in bracket, plus 6 minus 6i. We want to add up these two complex numbers. The first thing to do is to write the real parts out, or to open the bracket firstly, which is 7 plus 3i, and then plus 6 minus 6i. Now add up the real parts together, which is 7 plus 6. And then the imaginary part together. The imaginary part is the 3i minus 6i. So at the end of the day, we have 7 plus 6. That will give me 13, please. My equal to. So 13, the real part, plus 3i minus 6i. Okay, that will give me, not positive, but minus 3i. So that is the solution to the first one. Quite easily done. And you can do the rest. Just adding up the real part to the real part and the imaginary part to the imaginary part. For the B part of this question, we have 6 plus 5i minus 3 minus 4i. In this case, this is a subtraction. So all we just need to do is firstly open up the bracket. So we have 6 plus 5i, now minus 3 plus 4i if you open the bracket. So combine the real parts with the real parts. The real part is 6 and minus 3. So 6 minus 3, and then we have plus 5i plus 4i. So at the end of the day, please, my equal to, at the end of the day, we have 3 plus 9i, and that's all. So we can take our C and D and then do them likewise. So quite easily done. For the C part, we have 4, sorry. Again, like we did, open up the bracket. So and then combine the real parts. If we combine the real parts, easily I will just have 7. Then minus 5i minus 2i will give me minus 7i. And that's all. And we can take the D part of this question. So addition of complex number is quite an easy one. The D is 3 plus 5i in bracket minus 5 minus I in bracket likewise. So we can open up the bracket now. If you open up the bracket, we have minus 5 plus I. And then we can just sum them up like that. 3 minus 5 will give me minus 2. And then 5i plus I will give me plus 6i. So that's that about that. Quite easily done. Let's go to multiplication of complex number. Multiplication of complex number. So example 2 in multiplication in complex numbers. Simplify the following. The A part of this question says 3 plus 3i, all in brackets, then multiply by 4 plus 6i in bracket as well. And so all we just need to do here is to use the 3, our normal multiplication. 3 times 4, that will give us 12. So this is equal to 12. Then 3 times 6i, that will give us 18i. 18i. And then 3i times 4, that will give us 12i. And then 3i times 6i, that will give us 18i square. So we have 12 plus 18i plus 12i will give me 30i plus 18i square will give me 18 into bracket of, our I square is minus 1, so this will be minus 1. So at the end of the day, we would have 12. And then this 18 minus 1 will give me minus 18. I will write it with the real part. Then plus 30i. And so at the end of the day, what we have is minus 6 plus 30i. And that's the solution to the A. And that's all. Let's take the B now. Okay, here 5 plus 8i in bracket multiplied by 6 minus 3i in bracket as well. So likewise the same, use the 5 first of all to multiply the 6 use the 5 to multiply the 6, and use the same 5 to multiply the 3i, just our normal multiplication. So here we would have 5 multiplying 6 firstly will give us 30. So we have 30, and then 5 multiplying minus 3i will give us minus 15i. And then now use the 8 to multiply the 6 firstly, and use the same 8 to multiply the 3i. So 8 multiplying 6 will give us plus 48i, and then 8i multiplying minus 3i will give us minus 24i squared. So that's it. So at the end of the day, we have 30 minus 15 plus 48 will give us plus, we have plus 33. So plus 33i, and then minus 24. But again, remember we have I squared. Yes, I squared give us minus 1. So at the end of the day, we would have 30. I'll do this with minus 24 times minus 1. That will give me plus 24. So that will have plus 24 here. Then before the 33i. So eventually we have 54 plus 33i. 33i. And so we can take our C and our D and do likewise. Our C is 2 minus 3i all square. And you know, because it's all square, it will be 2 minus 3i multiplied by 2 minus 3i. If you do this on your own, you will have the answer. So following the steps, we have final answer being minus 5 minus 12i. You can just look at the steps. It's what we've done before. Then we take our D now. So if we do our D also, we have 19 minus 8i. Now let's go to conjugate of a complex number. Conjugate of a complex number. Okay, conjugate of a complex number. You see, two complex numbers are said to be conjugate if their product is a real number. This is just similar to conjugate of a sword, but even if you don't know that, it's not a problem. Now, for the first one, solution. For the first one, the conjugate of 4 plus 5i is simply 4 minus 5i. And the reason is because if you multiply these two complex numbers, that is 4 plus 5i, multiply by 4 minus 5i, it's conjugate. These two complex numbers are said to be conjugate now because one is having plus, the other one is having minus. If you multiply both of them, you have a real number. Let's try that now. 4 times 4 will give me 16. 4 times minus 5 will give me minus 20i. 5i times 4 will give me plus 20i. And then 5i times minus 5i will give me minus 25i squared. So at the end of the day, we have 16 minus 20i plus 20i. We cancel out. So these two become gone. And then we have minus 25. And then multiplying by I squared will give me minus 1. So we have minus 1 there. So at the end of the day, this will give me 16 plus 25, which actually is 41. This is what we're trying to say, 41. So you see that the final answer is a real number. So that goes for any other one. Let's take the number 2 now. I will not multiply, but if we do that, we would have that. So conjugate of a minus bi is actually a plus bi. That's the conjugate, a plus bi. And conjugate number 3, conjugate of 5 minus 3i is actually 5 plus 3i. And like I said earlier, the reason is because when you multiply conjugates, it will give you a real number. The complex parts will be out. The next thing we will consider is division in complex number. Now, division in complex number. See, when dividing a complex number by another complex number, we simply multiply the numerator and denominator by the conjugate of the denominator. Let's look at this example 4 now. You say evaluate the following. We have the I question, which is 3 plus 2i over 1 minus 3i. Let's begin with that first. That's our I. Now, the first thing to do is to multiply this complex number by its conjugate. Multiply the denominator and numerator by the conjugate. Conjugate of the denominator is 1 plus 3i. So I multiply the numerator by 1 plus 3i and also multiply the denominator by 1 plus 3i. If I do this now, we would have 3 times 1 will give me 3, while 3 times 3i will give me 9i. And then 2i times 1 will give me 2i, while 2i times 3i will give me plus 6i squared. So all over, we take the denominator now. 1 times 1 will give me 1, and then 1 times 3i will give me 3i, and then minus 3i times 1 will give me minus 3i, and then minus 3i times 3i will give me minus 9i squared. So this is what we have. And now, at the denominator, we have 3 plus 9i plus 2i will give me 11i. 11i. While plus 6i squared will give me plus 6. The I squared itself will give me minus 1. All over. And then, at the denominator, we see that plus 3i minus 3i will eliminate one another. We'll be left with just 1 minus 9 into the I squared is minus 1. So we have this. So eventually we have 3 plus 11i. The 6 times minus 1 will give me minus 6. All over 1 plus 9. So if we further simplify, we have 3 minus 6 will give me minus 3 plus 11i. All over 10. We can leave this like this or write it as minus 3 over 10 plus 11 over 10 I. And this is our final answer. I'll leave it in decimal. Let's take the second one now. Again, the approach is the same. Just multiply denominator and numerator by the conjugate of the denominator. Let me say the conjugate of the denominator is 5 plus 3i. So multiply 5 plus 3i. Again, multiply this 3i. Multiply by 5 plus 3i. Again, we would have 3 times 5, that is 15. And 3 times 3i will give me 9i. 5i times 5 will give me 15i. And then 5i times 3i will give me 15i squared. All over 5 times 5 will give us 25. And 5 times 3i will give us 15i. Minus 3i times 5 will give us minus 15i. And then, sorry, okay, I think I made a mistake here. Let's correct that now. It's correct. So minus 9i squared. 9i squared, please. Minus 9i squared. So we further simplify now. We would have 15 plus 24i minus 15. How did I get that? You know, this 15i squared, 15 to minus 1. So I just want to skip showing that. So now the next thing, the middle terms at the denominator will eliminate each other. We're left with 25 plus 9. So at the end of the day, 15 will eliminate 15 at the numerator. So we're left with 24i all over 36. 34, sorry. You can further simplify it to say this is 12 over 17. Alright, so that's that about this. Let's take the last one. Okay, I noticed a little bit of mistake to be corrected here. Please, this ought to be 25. 25, not 15. 25i, please. And that will give us 34. Not so 34, please. So at the end of the day, we have just I as our answer. I'll correct that now. So you can cross-check that. But let's take this number 3 now. The number 3, I will just show the steps. You can try this on your own. You can pause the video and try on your own. But when you finish, your solution should look as like what we have here. So the 3, this is what your solution should look like. Now let's take equation involving complex number. Equating 2 or more complex number. You see, 2 complex numbers are said to be equal if both the real part and imaginary part are equal. What I mean is that, for instance, let's say we have x plus yi, for instance, that it is equal to 2 plus 3i. These two complex numbers are equal only when the real part here is x, is equal to the real part on the other side, that is 2. That means when s is 2, and also when the imaginary part, when the y is equal to 3, when y is equal to 3. And that's the only condition to which these two complex numbers are equal. Let's take some equation involving complex number now. Example 5. Let's look at this question now. Evaluate s and y if x plus iy is equal to 3 minus I plus 1 plus I. The first thing we do here, before we can say we are comparing or we are saying the real part is equal to the real or imaginary part, I look at the right hand side and I multiply it by its conjugate. I mean that I will write x plus iy is equal to, when I come to this right hand side, we have 3 minus I over 1 plus I. I will multiply this right hand side by its conjugate, that is 1 minus I all over 1 plus 1 minus I as well. And this will give us obviously 3 minus 3i minus I plus I square all over 1 square minus I square. I'm just taking it firstly. So again, we would have 3 minus 4i minus 1 all over, at the denominator we just have 2. We just have 2 because 1 square is 1 and I minus I square is also 1 plus 1. So we add that together. So this will just give me 3 minus 1, which is 2, minus 4i all over 2. If you take your simple steps, so you still get what we have here. When we get here now, what we do is to simplify further. So we would have 2 over 2, which is 1 minus 4 over 2 will give me 2. So at this point is where we compare that if these two complex numbers are equal, obviously the real part will be equal to the real part. It means that hence x should be equal to 1 and the imaginary part should be equal to the imaginary part, and y is equal to minus 2. This is how to solve this. There are other methods of solving too, but I think this is far easier than maybe another, or you can try other method, but I will stick to this. The same thing goes on to this in this example 6. I will write a minus bi is equal to, again I take the conjugate of the denominator of the right hand side and multiply the numerator and denominator by it. So that 1 minus 2i now over 1 minus 2i. I think you can try this on your own, but if you do that, you will come to this step where we will be now. So you will have this now, and again, by the time we get here, we compare the real part with the real part and imaginary part with the imaginary part. So here it will be a is equal to 1 over 5, and then minus b will be equal to minus 7 over 5. Hence, therefore we can say b is equal to 7 all over 5. So that's what we simply have. You can try these exercises on what we've learned now.